The record is going. All right. So thanks everyone for coming. Welcome to the latest Azure Intelligence Edge brief, or what I like to call the Aieb call. And this will be the third installment of it. And I think I'm very excited about this particular topic. We have Marvin Garcia coming in for one of our great CSAs or Cloud Solutions Architects to talk about a POC that we had recently did, or I had the privilege of tagging along, if you will, and joining in on the fun for this in a really interesting use case. So before we get started, we'll go ahead and just go over a few things, just an overview of this call, how we run these things, a few tidbits of news, but then I'm going to hand it over to Marvin to take control and go over the topic of the day, which is detecting safety violations using Azure Data Box Edge and cognitive services. So should be a good topic. So let's go ahead and get to it. And so I'll also do Q&A, and I've got a few of my friends here on the line. So if there's any questions, feel free to use the IM chat window as we go through. Just a couple of housekeeping things. So again, this call is a 30-minute brief. It's open to everyone. So as you can see in the people window, that there are folks inside Microsoft, outside Microsoft, got some partners as well. That's intentional. This call is absolutely open to everyone. And therefore, the second item is we don't and really can't share anything from a non-disclosure information, confidential information type thing. So just keep that in mind as you ask questions. We're not trying to be rude or coy. Sometimes we just have to essentially defer the answer, if you will, if it has to do with something NDA. The other thing, too, is as you can see, we're using Teams, which is a wonderful collaboration tool as long as the crowd size is under 100 or so. We're going to keep using that for now, assuming that it works out. What that means is everybody has an equal partner. You can mute and unmute yourself and maybe cause all kinds of problems for those of us trying to present, but assuming everybody knows how this works. So please mute your phone when you're not speaking, and if the crowd's too dense, try to keep questions and stuff to IM, and we'll do our best to answer as we go along. We will, in our recording these calls, and I've got a YouTube channel that I've set up for this at that AKA link in the window there. So I'll make sure to get that posted as soon as we're done with the call. I also have, and I don't have this, the AKA link for AIEB-topics, I believe, sends you to a GitHub README. If you click back to the one up from that, that's where I'll post PDF versions of this deck. So, and all the decks. So you'll both have the recording as well as PDF versions of any of the decks that we go through as we're going to go through today. All right, so let's get started, and I'm just going to quickly go through this and give all my time to Marvin to discuss the awesome solution POC that we went through last month. Before I do that, just a couple of tidbits. For those of you that are familiar with and are fans of Azure Stack, no surprise, 1907 has dropped. Actually, there's a hot fix, and I haven't been able to read the release notes. I just saw on one of my demo units literally this morning, so I don't exactly know what that's all about, but 1907 is out. You can read all about the release notes, and essentially a couple of the highlighted enhancements of this release are listed here, as well as at that link. Last month, cognitive services, which is actually interesting and a good segue to what we'll be talking about today. But just to let you know that we have released cognitive services. There are containerized versions of pretty much all of the cognitive services that Microsoft offers, such as face and vision and text detection and all of that good stuff. This link will take you to specifically, well, now that you have a containerized cognitive service that you can use, what's a good way, what's the best way to use that in an Azure Stack environment. So that's what that link is there, and that went live a few weeks ago. And then Azure Data Box, in that family, we have this thing called Azure Data Box Heavy, which is interesting. So it's a wheeled heavy data box, which is full of drives. I believe it's up to around 1 petabyte per data box heavy. So if you're looking to move literally almost a ton of data from your data center into Azure, that is something that is made more possible by using our Data Box Heavy, which is has just gone to general availability as of very just a couple of weeks ago or about last month. All right. And that's all I have for announcements and table stakes. So for now, let me hand it over to Mr. Marvin Garcia. He's a cloud solution architect. I had the privilege of working with him and the team for a particular manufacturing customer of ours. And with that, I'm going to let Marvin take it. Go ahead, Martin. Or I'm sorry, not Martin, Marvin. Sorry.
Thank you, Kevin. Can
Yep.
you hear me all right?
I can hear you okay. Anybody, one or two, want to IM or unmute just to make sure we don't have any weird audio? I think
Yes, I
we're
can
good.
hear him.
Awesome. All right, take it away,
Perfect.
Marvin.
Well, thank you very much. Happy Friday, everyone. Thanks for joining. Hopefully, you will find this one very interesting. I'm Marvin Garcia, Cloud Solutions Architect for the South Central region, and I'm going to go through one of the POCs that we recently did with one of our customers in the region. So I'll try to go through a quick explanation and briefing of what we did, and head to the good stuff as soon as possible. So just to give you a quick justification and overview of why we did this POC, my customer has almost 40 plants worldwide and factories for production of fuel tanks and fuel cells. Their product quality is outstanding, what they deliver to their customers, but they have concerning increasing scrap levels in those fuel tanks. Now, some of the reasons of why that happens is because floor employees on the floor, the factory floor, they put defective and suspicious tanks on the floor, and due to lack of space or racks available to place them, or just out of laziness, and some of those tanks deform themselves when they're put on the floor if they spend too much time on the floor. So that leads to an increased scrap and objects in the way of work. That is a safety concern when you're walking by with all this equipment and you find things on your way. And also, employees on the factory floor, they sometimes are using their cell phones when they're working and not wearing safety glasses or goggles, and that is a safety code violation. So they wanted to tackle this, and the IT department wanted a quick win to present to the business to show how IoT and some of these technologies can really make a change, can provide some insights on their business and what's happening, and enable them to take actions. So, sorry, I think this will be easier. So some of the requirements was to implement a POC that could be automated, cost-effective, and scalable to identify some of these situations on the factory floor. They would also like to have notifications to floor managers whenever a safety violation is detected, and provide insights to leadership about the safety code compliance. And the approach we took was using data about Edge plus the containerized version of cognitive services specifically for custom vision. Now, the scope of the POC that we delivered was about capturing images from two IP cameras that they installed previously to identify these safety violations. They put two cameras in two different holes that they would like to use as a pilot, and they started recording the footage of those images about 1 week before we got there, so we could have some data to work with on day one. Then the POC should also send notifications to floor managers through different channels in case they cannot read an email, they can get a message, or they can see a ticket created or something like that. And also providing reporting and insights for the safety violations. And one of the latest requirements that came up is that every situation can have its own verification frequency. So, for example, we talked about tanks on the floor and also people not wearing glasses or using their cell phones. If people are putting tanks on the floor, they have been doing that already. They want to know when it happens, but they don't want to be notified every 5 minutes, because at that point, those notifications become noise, and that's it. You won't be doing anything with it. So you just notify that every hour or so, and how many times you saw that incident within that period of time. And if you see someone not wearing glasses, you would or using their cell phones, you would like to be notified right away, like every 5 minutes or so. And then provide an easy and repeatable way to improve the accuracy of the AI module. So this is the architecture diagram of what we put in place. On the bottom left side, you have the developer machine that was my computer using Visual Studio Code with all the Azure IoT Edge modules and SDKs, and using Docker for Linux. Now, we have two different boxes here. We have what was on the customer plant and what was on the Azure cloud. On the customer plant, we installed, with the help of the customer's IT department, we installed and racked the Databox Edge. Previously, we configured it, we connected it to their subscription. By the way, kudos to the product group. It's an amazing solution, and the things that it can do are it's amazing. So we put it in place, we configured it, we set up all the things. There is plenty of documentation online if you want to go over that. If you have any questions, you can hit me on offline for more details about it. So they have the two IP cameras. We have the Databox Edge on the same network, and the flow was that I created three different containers, three different modules. Well, it ended up being four. For IoT Edge modules. One of them was to capture images from those cameras and store them locally. The second one was to analyze that information. So basically, you get every image and then you send it to its respective Docker container for the object detection module. And we had two different object detection modules, one for each camera. So the flow was that locally, I would configure my solution on Visual Studio Code. I would train my custom vision model with the data that I had at my disposal at the time. Then once I have done my training, I'll show you in a minute how that looked like a little bit. I would do my training. Once I'm satisfied with the results, I would then download my Docker version of my module and add it to my solution. And then I would push all of these images to a container registry on the customer subscription. And from there, I would deploy those modules into the Database Edge, the Edge runtime, the compute piece of the device. Internally, it would do, like I said, it would grab images, store them locally. Then another module would grab those images locally and would analyze them against the AI modules. And whenever something happens, on the top right side, top right corner, whenever there was something to notify, it would send an email message to the Event Hub that would be sent two different ways. The first way, it's sent to a service bus that would be grabbed by a Logic app to send an email to a distribution group. That was the first notification process. That could also include a text message from Twilio or something like that, or connect to System Now or any other ticketing system. And the second path was for reporting purposes. So the IoT Hub would also send the messages to Stream Analytics, and then they would be displayed on Power BI. And of course, images that were relevant for any further analysis, revision, validations were stored on an Azure account. But that's done automatically by the Databox Edge. Whenever you put something on a shared folder, it synchronizes it with the cloud based on a schedule if you want to set one. Now let's take a quick look at the custom vision object detection tagging strategy. That is something that we we struggled a little bit on looking at the best results possible. This is a sample image from one of the cameras, and you can see all of these tanks are on the floor right now. The ones on the top center of the hole are in a rack, so those shouldn't be recognized. And then my first tagging strategy was to identify every individual tank, and I would create individual tags for every tank, and then a big one for all of them. And after my training, my precision and recall was very low. Now, for those of you that don't know what precision and recall means in these cases, precision means out of all the times that the module called out a tag, how many times out of those it was right. It was actually what it's supposed to be. And then the recall was out of all the times that there was a tank on the floor, for example, the module called it out. So precision is how many times you were right. out of the times you said something, and the recall is a ratio of how many times you missed that there was something that you should have identified. In this case, we wanted to have a high recall so we wouldn't miss something out, because we would have later a validation process by a human being. And so false positives are not that important, but we want to be able to capture as many times or events as possible. So I had to redo my tagging strategy because these numbers were too small or too low. And then I started, instead of tagging every single tank, just started doing larger tagging areas, and the recall increased a lot compared to the previous result. And then when I just did one big area covering some shadows, floor, surroundings of the tanks, it went up very high. So at this point, we can see that it was a sustainable recall percentage, a very high precision number as well, and that was something that we could work with, and the customer would be happy with the results. Now, I'm not going to dive into the code. It's already available in my repo. It's Marvin Garcia Edge Safety Violations Detection. You can feel free to go there and take a look at it. It's still a work in progress. I'm still making some changes. But let me just walk you through the approach we took. So imagine that you're deploying a container image into a box that is remote. You want to make this as repeatable as possible and scalable as possible. So one of the things we said is, how do we pass the settings and the information for every container? I don't want to hard code that in my Docker image. I want to be able to change that information and just pass it along, and it'll pick it up. So we put an environment settings file which path would be passed as an environmental variable. And the first thing the containers would do is read this document and read the settings they needed. And then a later requirement for the POC, like I said before, is that every tag or every situation must have its own frequency. So the first iteration of the POC was every 15 minutes, I'm running for every camera, for every tag that I have available or that I should recognize, and I will analyze it and I will notify the end users. They didn't want that. They wanted to be they wanted it to be different. So this is the template for the environmental settings file, and you can find this one in the repo. So basically, we have camera devices. This is an array where you can specify as many cameras as you want to, and you have information like the endpoint, the IP address for the cameras, the username and password for credentials, the local folder where you want to store the images for this specific camera, and the output folder on the share that is going to be synchronized with the cloud. And then this is the capture time interval. It basically means how many times or how many minutes you're going to wait to go and analyze and take a picture for this image. And then for every camera, like I said, you may have one or multiple AI modules from cognitive services. So this is also an array that has the scoring endpoint of the module that is running right next to this one on the edge device, and the tags that you're looking for. So this one, in this case, it could be tank on the floor, person with cell phone, person without glasses, the probability threshold that you would like to apply, and the time interval. So as you can see in this case, it is 60. That means 60 minutes. Every 60 minutes, I'm going to be checking for this tag. I'm not going to do it every minute or every 5 minutes. And then this second tag would be person without glasses. It would be every 5 minutes. And then additionally, we added a properties section where you can add whatever else the containers or the code may need. And so that's how, which all of this is possible because the DataBox Edge, the SDK, it provides a timer, and it has a counter that it keeps increasing every time the timer gets called. And that made it possible for me to set up a timer internally in the code and then just count, is it time to check for a tag? Is it time to check for tag number 2? And so on and so forth. So now just to show you a little bit how the flow is. So when you guys go to the code, you can see what I did, and it makes more sense. The stored image module flow would be called every minute, and it would say, are there any cameras for me to look into? Yes. Are there any AI modules for those cameras? If so, are there any tags that I should look into? If yes, is it time to capture an image for this camera? If the answer is yes, then I capture the camera and store it locally. So that means that if I run this with this previous configuration, and I'm running this interval every 60 seconds, and I'm capturing images every 5 minutes of this. After an hour, I would have a couple of images already stored. I wouldn't have 60 because it doesn't capture images every 60 seconds or every minute. It would do it every 5 minutes. And if any of these answers would be no, then it just ends and waits for the next iteration. And then the analyze image module flow, it'll be pretty much the same questions, but let's go through it. It would also run every minute, and it would say, are there any cameras that I should look into, any AI modules, or any tags inside those AI modules? If so, is it time to analyze that tag? It's not the camera anymore. It's now, should I analyze that tag specifically? If so, are there any tags in the tag folder? Because the previous one put an image on every tag that should be that it's related to that camera. So if so, if there are any images in that folder, I will call the object detection module for every single file that I find in that folder. If I find any tags that are above the threshold, the probability threshold, then I move the image to a flagged share folder. I send a message to the hub containing some information about the tag ID, the module that recognized it, the URI for that, the location in the search account on the container for that image, and the prediction results, and specifying the tags that were found. And then after that, I just delete the image from the local folder, and that's it. That ends. So, and if there were no tags that were flagged for the object detection module, it would just move the image to a different folder and would end. This is not a requirement, but it was necessary for us to make sure that the modules were actually recognizing correctly. So we wanted to have a flagged folder and a safe folder, and then we went through a safe folder and we made sure that none of those were. It's just to improve the recall, basically. And well, out of all this awesome experience, there were some lessons learned. Some of the things that you might be aware of when you're facing a project like this. So for the DataBox Edge, just be aware that it might take up to 12 days to arrive to the destination. That's in our case, it was like 9 or 10 days since it was ordered through the Azure portal. With a 30 megabytes internet connection, it took about 4 hours to apply updates. But we were told it could be way more than that. So I guess the devices are arriving with less pending updates, or we got lucky, but we were told that. And just so you know, the update 1905 is needed if you want to use FPGA compatible modules. Now, when you're configuring the compute layer of the DataBox Edge, it is recommended to do the advanced configuration because it allows you to use to push multiple containers, multiple images, and it gives you a more advanced version. If you use the common, the basic one, it will not give you that much freedom to play with in a scenario like this one. Debugging the device is very complex. It's not complex, but it's complicated. I mean, you require access to the same network where it is, and then you need to connect to it through PowerShell or a Linux console, and then you start going through the logs of every container. You can do that, but just the fact that you need to be able to connect to that device from the network, it represented a challenge. In our case, I had to request VPN access to my customer. That lasted that I had to wait for it for about 10 days. And after that, I was able to do it. I'm hoping they're working on it, but that's the only downside that I see for this device. The database edge, it also has a timer trigger. So it has two different triggers. One is for file trigger. Every time a file is placed on one of these chairs, it'll run something, or a timer trigger. The timer trigger, it works perfect if you're doing something like cleaning a folder, deleting files from a specific source, but it is not recommending for recurring code invokes. So for example, in this case that I was supposed to run my container every minute, it is not meant to do that. In that case, it's better to handle a timer inside your code. And like I said, you can incrementally keep track of your executions and add that to your logic if you need to. Um, Regarding the IoT Edge module development, I tried to use Visual Studio the first day. It wasn't that good, the experience. So I switched to VS Code. It was way better. I recommend Visual Studio Code definitely to code IoT Edge solutions. I mean, this is kind of common sense and everybody has an opinion, but I decided to use lowercase for everything. It proved to be way easier since you're working with Linux and all that. It made it all more uniform and consistent. Um, Quick advice, try not to use the build and push IoT Edge module functionality from VS Code. So if you see your modules on the left side and you right click one of them, you're capable of, you can build and push through Visual Studio Code, but it keeps using the latest tag. It never increments it. So if you want to be able to trace your changes and if something goes wrong, you want to go back to a previous contained Docker version, you won't be able to do it that way. In my case, I had to create a PowerShell script just to differentiate what module you want to work with this time, and then it'll increment the version and it will build and push my image. But ideally, the best way to do this is creating a DevOps pipeline whenever you make a change in your code, either by downloading the Docker version of your cognitive services module and then you unzip it in your local file on your computer. And whenever the repo recognizes those changes, it just goes ahead and builds and pushes the images to the container. That'll save you a lot of time when you're working through this. This POC took 3 days, 2.5 days. And the amount of time that I spent upgrading images, building and pushing, it was worth to set up a DevOps pipeline and get on with it. Now, there is a trade-off. In this case, there was a challenge when designing the solution. There is a trade-off between creating one module to analyze all the cameras or create one module for every camera. Because we wanted it to be scalable and repeatable, we decided to go with the environmental settings, the JSON file, and created just one module that would store images, one module that would analyze those images. And then it doesn't matter how many cameras, how many tags, how many modules you have in there, it'll sort through all of that, and you just have to maintain one single piece of code and don't have to duplicate it or maintain more code and or specific for every camera. Another one, use async methods as much as possible. It'll help you with parallel tasks, so you can process more images in parallel and see the results faster. It's just a good practice. And log everything. Start adding logs to that code, as many log entries as you consider necessary, because they will help you a lot once you can connect to the edge device. That's the only way you can know what's happening inside your container. And if something went wrong, the logs will tell you. So, and then you can use log levels to ignore. For example, if you're debugging, you just set the log level to debug, and then once you're moving to production, then you just set it to information, and it'll discard most of the messages that you put in there. Some of the lessons learned with cognitive services and custom vision is that, well, like I said before, some situations may need high precision, others high recall. In this case, we valued recall over precision, even though we got a higher precision every time, but it was we were aiming for the highest recall possible. I cannot say this enough. The larger the data set, the better the results. Some challenges that we face too is that you need to make an even and balanced data set. You need to have enough data for both scenarios for the module to recognize those cases. So the more data you have, the better. Don't use fast training for the custom vision module. It is meant for very easy scenarios or very small amount of data. For complex POCs like this one, when it was trying to recognize those tanks, the fast training didn't work. So there is an advanced training process where you can set up a budget, basically how many hours you want it to use for training. It doesn't have to consume that all, but it will give you way, way better results after that. And for the IP cameras, of course, it needs to be a camera that it's an IP. Well, the ones that we decided to use, IP cameras, and that you can take snapshots and images out of that. That will make your life way easier. Ironically, one of the things that kept us from moving forward during this POC was the authentication method in the cameras. So we were expecting basic authentication, and it was
wasn't it like it was like digest or something weird?
Yes, it was set to digest. So we spent about 2 hours trying to solve the IP camera authentication. After that, everything went smoothly. But there's always that tiny thing that you miss. And try to choose a compression algorithm that'll give you a good trade-off between image quality and the resolution, so the module can pay attention to good things. For example, when we were looking at the people without glasses, they're just walking by, they're not stopping in front of the camera. It might be a challenge to recognize that the person who's wearing glasses without the right resolution, but you don't also want to overflood the DataBox Edge device. Even though it has great storage capabilities, you don't want to use images that are too heavy because you might run out of space eventually. And that's it. That's
Awesome.
all I have. I don't know if you have any questions. I haven't read the.
Yeah, so Marvin, there's been a few questions back and forth, and I think there's nothing out there hanging, I don't think. But yeah, so we've addressed questions on the IM as we go, and we are just a bit over time, and that's okay because we're at the end. And so again, the next meeting on this, if you've got the recurring meeting on your calendar, that's great. You know, it's a week from this next Friday, so it'd be our next call will be August 16th. Pay attention to the topics, aka MS topics link, and I'll be posting that topic shortly once I get that nailed down for that next call, which will be 2 weeks from today. But I appreciate you guys hanging in and listening to this. As I said, I recorded this, so it'll be available to you and also your friends. So please tell your friends and family about this and share with the recordings and the invite, and love to have them on the next call. And with that, I'll go ahead and release you all to a weekend. Have a great afternoon and have a better weekend. And we'll be talking to you soon.
Thanks, everyone.
Thank you.